Hi guys, today we're going to discuss electron configurations. Okay, so electron configuration basically is just a summary of where to find the electrons in the subshells around the nucleus, right? So before we dive into subshells, what is shells? Okay, so shells is basically the quantum number that we know, right? 1, 2, 3, 4, 5. They represent different energy levels, right? Shell number 1 being the highest energy level. Okay, so inside each shell, they have different numbers of subshells. Okay, for example, in shell number 1, there's just one type of subshell, which is S subshell, right? So it's 1s. Whereas in the second shell, we have more subshells and more subshell types, right? In our second subshell, in our second shell, not only do we have S subshell, but also the P subshell. Okay, so it's 2s and then 2p. Okay, and then in our third shell, we have even more, being 3s. 3p and then 3d. Okay, and then the fourth shell we have a 4s, 4p, 4d, and 4f. Okay, and then the fifth one has 5s, 5p, 5d, and then 5f. Okay, f is the maximum. There's no more g subshell. Okay, perfect. So that's the idea of subshells. Okay, and then inside each subshell, we have different number of orbitals, right? Like this S subshell, it has only one orbital, which is the sphere shaped orbital that can have up to 2 electrons, right? And then also the P subshell has actually 3 orbitals, if you remember XYZ, right? And then also the same number of electrons in each orbital. Being 2 electrons, then 3 orbitals will make this P subshell have up to 6 electrons, right? Okay, and then the D subshell can have up to actually 5 orbitals, so it would can have up to 10 electrons, right? And then the F subshell can have 7 orbitals. That gives 14 electrons maximum. All right. So that's the idea of subshells, okay? So let's see how we write the electron configuration. So for each atom, to write the electron configuration, we have to follow something called Aufbau principle. I'm pretty sure I butchered the pronunciation, but the idea is you go like this. You go like 1s, then 2s, and then 2p to 3s, and then 3p to 4s, and then 3d to 4p to 5s, okay? And then so on and so forth. Okay, so it looks pretty clear, right? It's just those lines that I drew. But one thing to pay attention, if we align all these subshells linearly, you can see that, okay, we're gonna fill 1s first, right? And then next we fill 2s, okay? All good so far. And then we fill 2p, right? And then after 2p, we do 3s, okay? It's still good so far, okay? Now the tricky part is gonna come up, okay? So after the 3s, we have here 3p, right? And then 4s. So after 3p, it is not 3D, but 4S, okay? And then after 4S, it's 3D, 4P, and then 5S. What does that tell you? So that tells you, if you were to rank the energy level, you would find that 4S is higher than 3D, okay? And then 4p is higher than 5s. Okay, just keep that in mind for now. Okay, it's not like simply 1s, 2s, 2p, 3s, 3p, 3d, and then 4s. No, that's not the order. Okay, the order is 1s, 2s, 2p, 3s, 3p, and then 4s instead of 3d. Okay. All right, so that tells you the rank of the energy level. Okay, we have to keep that in mind for now and then use it later for writing out the electron configuration. Okay, all right, perfect. So on MCAT, you will be given a periodic table that looks like that, right? That looks like that. And then there's a good practice you can do is to label the blocks, the different blocks on this periodic table. So you form a mental image, and then during the test, you can just simply tell, okay, which block the certain element belongs to. So that's going to help you to write the electron configurations. Okay, yeah, just hear me out. We're going to do a couple of examples in just a minute after we label the blocks. Okay, so here, let's first label the S block. Okay, so the S block, they're right here. And then also this one. Okay, so we can say, okay, this is the S block. Okay, and then we can label the D block. Okay, so D block are basically stuff in the middle, those metals. Okay, this is my D block. Okay, and then we can go ahead and label the P block. We should have labeled P block first, but I just did it the other way. Okay, so this is the P block. Okay, which has 3 orbitals. Okay. P orbital. Okay, and then lastly, we can label the F orbital, which are not very much used for MCAT, but just for the completion. Okay, so that's the F orbital, right? And then the tricky part about these blocks is that you would intuitively think, oh, this is 1s, 2s, 3s, 4s, 5s, 6s, and 7s, and that is correct. And then also for the P, that's 2p, 3p, 4p, 5p, 6p, and 7p, right? So you would think, okay, this D will be 4D as well. No, that's not the case. So this is actually 3D, okay? This first line, okay? So it goes 3D, 4D, 5D, and then this is 6D. Okay. So this actually is the same idea as we just discussed. So as you can see, after 4s, it's 3D, right? After 4s, it's 3D. And then after 3D, it goes to 4p. Okay. And then after 4p, it goes to 5s. Okay. So that's why, the Aufbau principle gives us this order, so which creates this unique situation that you have to mentally know. Okay, all right. So now now here comes the meat of this video. Okay, so let's just do an example. How do we write the electron configuration? Okay, so for example, I would say let's do iron. Okay, so iron. So let's first find where is iron in the periodic table. Okay, so iron is here. Okay, it is here. So we know the first thing we find is the noble gas before the element, right? So the noble gas before iron will be Ar, right? Okay, so first we write Ar. Okay, all right, and then after Ar, let's look at this. So what are these? These are 4s, right? Okay, how many elements? 2 here. So we put 4s, 2, okay? And then after this 4s, we come to the D block, okay? It is, once again, 3D, not 4D, okay? Okay, and then 3D, but what number do we put here? Okay, so let's count. 1, 2, 3, 4, 5, 6, okay? So iron is the number 6, okay, on this D block, this 6th column. So we put a 3D6, okay, if that makes sense. Okay, let's do another one. Let's do ZR, okay. Let's actually use a different color, okay. Okay, let's do ZR, okay. So let's find where is ZR. Okay, ZR is here, okay, if you can see where I circled. So ZR, excuse me. So ZR is in the D block again, okay? So we have to mentally know, okay, this is 4D and not 5D, okay? All right, so now let's find the noble gas before ZR. So the noble gas before ZR is Kr, okay? And then after Kr, we see 5s, right? 2 elements. And then we come to the 4d, okay? 4d, and then if you count the D block 1 and 2, ZR is the second one, right? So there you go. You have the electron configurations, okay? Okay, so that's fairly straightforward. But MCAT, they can make the problem harder, right? For example, they can ask you to write the electron configuration for, let's say, cation, right? For example, what is the electron configuration for iron 2+, right? Or iron 3+, okay? So don't get intimidated by the cation, by the plus charge sign, okay? It just simply tells you 2+ means what? Means you have 2 less electrons, right? Because you lost 2 electrons, so you have 2 positive now, okay? So we just have to get rid of 2 electrons from here, okay? So let's get rid of the 2 electrons here, okay? Still, we have the AR, the noble gas, okay? And then the thing is, you get rid of 2 electrons. Do you get rid of the two electrons from the S subshell or the D subshell? Okay, so the rule is you always remove the electrons from the higher subshells first. Okay, so in this case, 4s is higher than 3d, right? Once again, if you see what I highlighted here. Okay, so that's why I say this is really important that you mentally know, okay, 4s is higher than 3d, right? 3d is not higher than 4s, even though 3 is like one number higher than 4, okay? But 4s is actually higher than 3d. So if that's the case, then we're gonna remove the electrons from the higher subshells 4s first, okay? So it will become 4s0. So 4s0, there's no, you simply don't have to write it. It's just 3d6, okay? All right, so now what if iron 3+? Now I have to remove 3 electrons. So you first move 2 electrons from the higher subshell, which is the 4s2, okay? You remove it from 4s2, and you have removed 1 more from the 3d orbital. So the electron configuration will become AR 3d5, okay? Perfect. So once again, just to reiterate myself, please remember the orders of these 4 things. Just memorize them, okay? Just quickly realize who has the higher energy level, and then you just remove electrons starting from the higher energy level, okay? But the opposite applies to if I give you an anion, right? You have to add electrons because anion means they are negatively charged. They have extra electrons. Then you fill them. You just fill them to their following the order. Okay. The next electron subshells. Just follow the order as usual. Okay. But when you remove electrons, please remove them from the higher subshells. Okay. Higher energy subshells. Okay. So perfect. So I would say that's basically what you need to know about this topic regarding MCAT. But just to be conservative, okay, I still want to talk about the exceptions, okay? So MCAT usually is pretty friendly. They won't give you too of a tricky problem, but if they do sometimes, okay, we all know they do. Okay, so the exceptions you have to know is for the D block. Let's label the D block. Okay, so the D block, column 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, there are 10 columns for the D block, and then to understand the exceptions, you have to have this mental idea about column 4 and column 9. Okay, 4 and 9. 4 and 9. So what's special about 4 and 9? Let's just do an example, okay? So let's say column 4, we have a CR, okay? So the configuration of CR, if you do it as we discussed, you would think, okay, the noble gas is AR, and then it's 4s2, 3d4, right? You would think, okay, 1, 2, 3, 4. Okay, it's 3d4. Okay, so that is not a case because the d subshell really wants to get another electron being 3d5. Okay, so being 3d5 means I will have to lose an electron here in the s orbital. So the correct electron configuration is actually this, not this. Okay, yeah, it's just that d orbital, like we said, it likes to have it has like five a d subshell has 5 orbitals, right? So it really likes to have all the 5 orbitals filled. So that's why like d5 is better than d4. It's just more stable. Okay, all right. And then what about the elements from the column 9. So the 9th column, let's also do an example, Cu, okay? Cu, if you use the traditional way, you would think, oh, it's Ar, and then 4s2, and then it's 3d9, right? You would think, okay, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, it's the 9th one. Yeah, but the same reason, like I said, because this d subshell, you can have up to 5 orbitals, and then if you fill all up, you can have up to 10 electrons. So D really preferred to have 10 electrons, okay, or 5 electrons, which is like half filled, if you will, okay? So if we add one more electron to the d orbital, d subshell, then the s subshell would have 1 less electron. So this is actually the electron configuration of a Cu, okay? Okay, I should stop the video here, but let me just tell you one more element. Which is this PD, okay? So PD is not in the 4th or 9th column, but it also is a special one, okay? So the electron configuration, it is actually not Kr 5s2 and then 4d8, okay? It is the d subshell is so eager to have 10 electrons, so it actually robbed both of the electrons from the s orbital, being Kr 4d10. Okay, the last one that I discussed is pretty low yield. I think it will be suffice to say that you just need to know the 4th and 9th column exceptions. Okay, all right, that wraps up the video for today. I hope that's helpful.